You got it. Hey, everybody. Thank you so much for coming. We're super excited to have Dr. Lockhart here. Dr. Shawn Lockhart is the Senior Clinical Laboratory Advisor for the Mycotic Disease Branch at the Centers for Disease Control and Prevention. He received an undergraduate degree in biology from Bellarmine University, a PhD in molecular biology from the University of Kentucky, and was a postdoctoral fellow at the University of Iowa. His research focuses on clinical mycology and antifungal resistance, with his current emphasis on international fungal laboratory capacity building. He has lectured on every continent but Antarctica, authored and co-authored on over 270 manuscripts and book chapters, and recently co-authored on the book, the 7th edition of Larone's Medically Important Fungi, which is a definitive guide for identifying fungi from clinical specimens. And he's here today to tell you all about how the CDC is doing their part in keeping us safe from fungal diseases. And thank you so much for being here. I'll let you take it away.
Thanks for the intro, Paul. And thanks for the conveners for giving me a chance to speak to you today. I don't usually get to speak in front of an audience that isn't filled with microbiologists. So this was a chance for me to think about what we do and how we can explain it to lay people. So let's just start out. Fungi really, they have an image problem. When we think about fungi, we're either thinking about Uncle Fred's nasty toes that he gets out at Christmas and nobody wants to see those. Or we're thinking about the Chinese food in the back of the refrigerator that's been there for 6 weeks and now has a layer of fungus on it that thick. Or maybe we're thinking about the fungi, like many at this festival, I'm sure, that we go out in the field and collect, like these morels. And just as a side note, I lived 15 years in Iowa, and they go crazy for morels. My best friend named his daughter Sierra Morel because he's that nuts about mushroom hunting. But typically, this is what we think about when we're thinking about fungi. Now, there's somewhere between 1 million and 6 million fungi. This is the number I chose, but depending on what you look at, it's between 1 and 6 million different species of fungi. And we've only named about 100,000 of them. So there's a huge, huge fungal world out there to be discovered. And the majority of the fungi we encounter on a daily basis are these. They're not the mushrooms that we see in the store or in the ground or even in our refrigerator. They're these microscopic fungi, these spores that we encounter every single day. Each one of us breathes in hundreds of fungal spores every single day. And because we have an intact immune system and we have white blood cells that live in our lungs and do absolutely nothing but gobble up fungal cells all day, we don't ever get sick from these fungi. But there are approximately 600 or so species, and we just keep discovering more every day, but 600 or so species that will cause infections in mammals. And, you know, out of those millions, there's a fairly simple reason that very few of them actually cause fungal infections, and that's because for the most part, fungi just don't grow at physiological temperatures. And if you can't grow at 37 degrees, you're not going to cause an infection in a body that's 37 degrees or higher. And by the way, 37 is same as 98.6 for those of you who don't use Celsius. But we can think about fungal diseases in 3 different ways. We have the superficial. Those are ringworms or tinea. Those are the ones that most of us have encountered as far as fungal infections go. About 1 out of every 4 people around the world will have a tinea infection at some point in their life. And then we have subcutaneous infections, these minor infections. They may cause a festering wound. This particular one was due to a cat scratch, and the cat had been infected with a fungus in its claws. But then we also have invasive fungal disease. And thank goodness, invasive fungal disease is a fairly rare event. The typical patient that we have who has an invasive fungal disease is somebody who's already got a whole lot of other things wrong. It's usually a patient that's older than 50. They have other comorbidities. They recently had surgery. They're immunosuppressed. They're on chemotherapy. The new one you guys might be familiar with, you're watching commercials, and a commercial for a drug you've never heard of that they never tell you what it cures, but at the end of the commercial they say, if you live in a certain area where fungal infections are common, do not take this, whatever imab. These are immunosuppressive drugs, and we're making tons of them right now. They work great, but they also lead to fungal infections. So we're seeing more and more infections, more than we've ever seen before. Now, when you think about infections and you think about outbreaks, you're usually thinking about measles or SARS or Ebola, monkeypox, and for the bacteria, legionnaires and cholera. These are the sorts of things that cause outbreaks. You don't really think about fungi causing outbreaks, right? It's just not something we think about. But the fact of the matter is they've been causing outbreaks for a very, very long time, just not in us. So, Cyphernectria parasitica is a fungus that came over right around the beginning of the 1900s from over in Asia, and it wiped out all the chestnut trees in the United States. 4 billion chestnut trees. The Appalachians were a completely different set of mountains. It was all filled with these giant, giant chestnut trees all the way from New York down to us. They are functionally extinct, completely gone. They will not grow. You can't plant new ones because that fungus is still in the soil, and 4 billion trees were wiped out by a fungus. Right now we have bat white nose syndrome, Pseudogymnoascus destructions. In some hibernacula, 90% of the bats are now dead due to this fungal disease. And I'm sure you guys have heard of the amphibian decline, the chytrid fungus, Batrachiochytridium dendrobates and Batrachiochytrium salamandervorans, literally wiping out amphibians all over the world. These are fungi, fungal infections causing these outbreaks and spreading across the world. And the last ones are pretty important, Magnoportha risei and Puccinia graminis. These are fungi that kill rice and wheat and destroy the world's food crop. So if we didn't constantly spray our foods with fungicides, over half of the rice and wheat would be completely destroyed by these two organisms, and it would cause worldwide famine. So whether we know it or not, fungi are all around us, and they're causing these outbreaks that we're just not aware of because they're not in us. But then came the last of us, and it's not going to happen. Cordyceps doesn't grow above 37. We're not going to see this, fungal-caused dystopia. But it's been really good for us because it gives us a chance to go out and talk about the fungi that we really are worried about. We're always ignored. Everybody thinks viruses and they think bacteria first, and no one ever gives any thought to fungi, especially fungal infections. People who get them are old, they're already sick, big deal. But with The Last of Us, we now have a chance to go out and say, hey, look, there's a whole group of people that we could save if we just identified these fungal infections. If we start thinking about fungus first, there's a lot of people whose either lives could be saved or lives could be extended just by thinking fungus. So I'm going to tell you about some of the outbreaks now that we've worked on here at the CDC. So the first one I want to tell you about is Fusarium keratitis in contact lens wearers. So keratitis is an infection of the cornea of the eye, and it can lead to blindness or even enucleation, where they literally take the eye out because the fungus is so bad they're afraid it's going to spread. And we had these keratitis infections among contact lens wearers in 2005 and 2006. There were over 250 cases reported. Many people lost their eyes completely. Many had to have corneal transplants. And it all came down to this Bausch & Lomb, this lens cleaner they were developing. This was supposed to be this magic stuff. You spray it in the tray, and you don't really have to clean your lens. You just put it in this lens cleaner, and everything's fine. The outbreak was caused by a fungus called Fusarium. And what you see over on the left, those are contact lenses. They put down on a petri dish, and they had so much fungus on the contact lens, they grew out like that. And on the right, you can see a picture of the bug itself. Now, we don't generally hear about Fusarium, and infections are usually in patients who are immunosuppressed, but Fusarium's played a big role in our food supply. We have one single strain of banana that we eat all around the world, the Cavendish. And we have that one because the last one we had, a monostrain, bananas have no seeds, they're all clones of one single banana plant. The last one was completely wiped out by Fusarium. And now it's starting to get into the Cavendish as well. So we may run out of bananas due to Fusarium. But in this case, they cause infections in people's eyes. So us at CDC and the FDA and some foreign governments, we all got this solution and we all plated it out. We didn't grow any Fusarium. It wasn't in the solutions. But when we went and we got opened solutions and we got the cases from patients who had their contact lenses in it, we could grow Fusarium out of all of those. So it wasn't actually the product being contaminated, it's just that Bausch and Lomb unwittingly developed a really, really good growth medium for Fusarium. And because people thought this new formulation, they don't have to wash their lenses off anymore, rinse it out, you do all this stuff when you had those old reusable lenses. Now everybody just throws them on the ground, but we used to have reusable and you had to wash them off. They thought with this new solution they wouldn't have to do that anymore, so they just put them in the tray, take them out, put them in, take it out. Fungus grew, and they put the fungus directly into their eyes. The next one I want to tell you about was a natural disaster in Joplin, Missouri. And we had cases of a fungus called Apophysomyces trapeziformis. What you're looking at here is the flank of a patient, and that white stuff you see is literally mold growing on the wound of that patient. This mold grows so fast, in a couple days you can literally cover the wound. So there was a tornado in Joplin in May of 2011. It was an EF5, which is the worst kind, winds over 200 miles per hour, and it hit a really densely populated neighborhood. There were 1,000 people injured, and there were 160 people killed. It was one of the most deadly tornadoes ever in the United States. But we got called in when they noticed severe fungal infections in some of the patients. 13 different patients had fungal infections. 5 of those patients died. What you're looking at again on the left, that is a scalp infection. This person had the skin of their scalp taken off as they were thrown by the tornado. They were found 150 yards from where they had started out when the tornado hit. And that is the fungus growing on the scalp of the patient. That patient, by the way, lived. But it was the fungus was a fairly common fungus called Apophysomyces trapeziformis, and it's found commonly in the soil. It's fairly ubiquitous. We see it all around, and it hardly ever causes infections. We get the occasional infection from people who were poked by a stick or something, but they're really, really rare. And yet we found them all in these patients. So we did the epi. We're thinking, okay, maybe it's a contaminated product, maybe it's a common procedure, but we found no commonalities among these patients. There wasn't any one product that all of them got. So where did this thing come from? The only thing they all had in common was 5 or more puncture wounds. So at least 5 puncture wounds due to flying debris. So for the first time ever, we did whole genome sequencing, meaning we sequenced all the DNA in the entire organism, thinking if we show they're the same, we can maybe figure out what they might have in common. And actually what we found was that some of them were exactly the same. The ones that have a straight line, that means they're identical to each other. But if you look at the rest of them, they're different. So we had all these different fungi, and they were spread out along the line of the tornado. The highest winds, every patient was in the place where they had the highest winds, which is probably why they had 5 or more puncture wounds. So this is what we think happened. Apophyzomyces lives in the soil, but it only reproduces in puddles, and it reproduces a couple times a year. 3 weeks before the tornado, they had rain almost every single day, and there were standing pools of water everywhere, which Apophyzomyces loves. It reproduces in water. It waits for water to reproduce. And when they reproduce in mass, they produce literally millions and millions of spores. Then comes the tornado. If you know, tornadoes are vacuums, so they suck up all of the water. They have all this wood and metal and debris. They inoculate all of that with fungal spores, and they shot them into our patients. And that's how we ended up with Apophyzomyces infections among tornado patients. No other species of fungus, just Apophyzomyces. This one is the worst one I've ever been involved with. This was terrible. Some of you may remember this because this was all over the national news, fungal meningitis following steroid injections. So we get a call from the Tennessee Department of Health. We work very closely with our state and public health departments. They had a patient with fungal meningitis. And fungal meningitis is very, very rare. It's a contamination of your cerebral spinal fluid and your brainstem up into your brain, but mostly the cerebral spinal fluid. And you usually only see it in immunocompromised patients. You don't see it in normally healthy patients, but this person was normally healthy patient. What we know about the patient, though, is they had received an epidural steroid injection for pain. So what they do, I've had a few, they hurt like heck, so this is something you only do if you have chronic pain, but they take a needle and they put it right above your spinal column and they shoot painkiller. In this case, it was a steroid. Within a week, we heard about 3 other cases, and a couple of the patients grew this fungus, Exorhilum rostratum, from their cerebral spinal fluid. So Exorhilum rostratum is a plant pathogen. It causes leaf and root rot, not human infections. It is heat tolerant. It'll grow at 37 degrees, so it can cause infections in us. And usually it only causes non-invasive sinusitis. So even when we get it in our sinuses, it can't get back into the tissue. It doesn't get into our brain. But when you inject it straight into a patient, what we found is this drug that was being made by a company in New England was contaminated with Exorhilum rostratum. So the drug that they were using, methylprednisolone acetate, it's not soluble in water, so it's this white powder, and you could shake the vial and literally see brown specks floating around in this vial. They then took the vial and injected it straight over the spinal column of patients who are having pain issues. Almost 14,000 patients were injected with this contaminated medication. So we opened the Emergency Operations Center at CDC, and our colleagues and our local public health partners literally contacted almost 14,000 patients, either by calling them or, if we couldn't get a hold of them, showing up at their door, knocking on them, making sure that they didn't have symptoms, because by this time patients were dying. It ended up with 753 patients infected, and 65 patients died from this fungal infection. It's the largest healthcare-associated outbreak of anything. Virus, fungus, bacteria, of anything. Largest healthcare-associated outbreak ever in the world. Here's a picture of Sanjay Gupta. We know him, a local boy. This is what was behind the building where they were making the medications. This is a recycling center, essentially a dump. The building had windows open. So all the fungus sitting in this dump is going into the windows of the building where they're making medications that are being injected into patients. When we looked inside these ampules of drug, we found a number of different fungus in there. Luckily, Paecilomyces formosus doesn't cause infection. Rhodotorula laryngis and Cladosporium cladospores don't grow above 25 degrees. And Rhizopus stolonifer, the last one on there, also only grows as high as 30 degrees. If this had been anything else, if this had been Fusarium or a different species of Rhizopus or one called Aspergillus, we would have had thousands of death. So we got lucky. We got lucky in that we had a plant pathogen and not a normal human pathogen that had contaminated this medication. Ended up in 5 people being charged. The CEO was sentenced to 15 years in federal prison. The chief medical officer was caught trying to get on a plane to Hong Kong. They caught him at the airport. He also got 15 years, but they were convicted of gross negligence. I was supposed to go up to the state of Michigan, which was one of the worst hit. Almost half the deaths came from Michigan, to testify because they couldn't believe these guys weren't charged with murder. So I was going to go up there and testify, and they pled guilty. So now they've been convicted of second-degree murder in a state court for gross negligence in making these drugs. The next one's a really weird one. It was bizarre for us. Bipolaris surgical site infection. So we got notified by Texas about 4 cases of a fungus called Bipolaris, and it was surgical site infections in patients who had cardiothoracic surgery. So that's open heart surgery. So we had open heart surgery, had surgical site infections. We thought it was due to construction because there was construction going on at a hospital. We very frequently get calls from hospitals saying, hey, you know, we're seeing this, we're seeing fungal infections. We don't usually see them. And then usually when you ask them a few questions, yes, there was some construction going on next door, and, you know, construction produces dust. Dust is filled with spores. They get into the hospital. So that's pretty typical. They did some remediation, and it kind of went away. So Bipolaris, very, very similar, very closely related to Exorahilum. Again, it's a plant pathogen, but it's a much worse plant pathogen. In the southern United States, this is a real problem on crops. But it's not a good human pathogen, and like Exorahilum, it only causes, you know, a superficial sinusitis. But it wasn't over. Within 1 year, we jumped to 21 cases, 10 different hospitals in 3 states. And they were all heart patients who had just had open heart surgery. We didn't see any other molds, no Aspergillus, no Exorahilum, no Apophysomyces, no Fusarium, just Bipolaris. And the weird thing is we didn't see any Bipolaris in patients who had other surgeries, just these open heart surgeries. Well, it wasn't a common emergency room or operating room because it was at 10 different hospitals. What in the world happened? So we're thinking, okay, another contaminated product. Nope, we could not identify a common product across all these patients. So again, we thought, well, let's do DNA fingerprinting. And so, like we did with the Apophysomyces, we did DNA fingerprinting on these isolates. And what we showed, not only were every isolate different, And, I said before, if it's a straight line, they're the same, and you can see there's very few straight lines. These are all different. Not only were they different from each other, but we had 3 different species of Bipolaris. Now, if you look at that blue bar down in the bottom, that was an outbreak of Bipolaris keratitis, a different outbreak. And you can see that all of those straight line identical to each other. So we can identify when things are identical. We did in that other outbreak, but all of these were different. So what the heck? So we went into the plant pathogen literature, and it turns out that Bipolaris has cyclic blooms. Every 4 or 5 years, you'll have a giant bloom of Bipolaris. We don't know why, but the farmers end up having to go out and spray like mad every 4 or 5 years because Bipolaris blooms like this. We didn't know about that. I don't read the agricultural literature. And knowing that there were blooms and cleaning up the hospitals, having increased awareness of the possibility of spores, stopped all the infections. But what we think happened, similar to the very first one I talked about, the Bausch and Lomb, all of these patients, the open heart patients, their wounds don't get closed. They keep them open, and they cover them in this gel. And although they didn't get the same gel, the gel's always the same formulation. And we think, once again, we just created a very good growth medium specifically for Bipolaris, and that's why we only saw it on these cardiothoracic open heart surgery patients. But those aren't the ones that keep me up at night. The ones that keep me up at night are this new one, Candida auris. Candida auris was just added to our current threats report at the CDC. Candida species, Candida are a yeast, and they're in us and on us. There's lots of different species. We have them in our gut, we have them on our skin. It's part of our normal flora. They're mostly antifungal susceptible, meaning when you treat them, they die. And they very rarely cause outbreaks. They used to a long time ago, but now that we know more about infection control, you almost never see outbreaks of Candida. I got this email in February 2015 on a Friday. It's always on a Friday, right? Always 4 o'clock on a Friday. So I get this email from my colleagues in Pakistan, who I'd been working with for a number of years. They had an outbreak of Saccharomyces, and they wanted us to do DNA strain typing. Saccharomyces is baker's yeast, what we put in our bread, what we put in our beer. It's a rare cause of infection, but it does occasionally cause infections, bloodstream infections in susceptible people. Healthy people, no problem. But they had all these infections. And it turns out when we did the strain typing, it wasn't Saccharomyces cerevisiae. It was this new bug that I'd never heard of before at the time called Candida auris. So we did a little digging. Candida auris is multi-drug resistant. 80% of isolates around the world are resistant to the major drug used for treating them. There's only 3 drugs. It colonizes skin, so it grows on patients who've been in the hospital. And when you're in a hospital, they do 2 things. They give you antibiotics, and they use really harsh detergents that get rid of all the good bacteria that grow on your skin. When that happens, Candida auris takes over. Those of us who have our normal bacteria, we don't get auris on our skin, but these hospitalized patients get it. Doesn't cause a rash, doesn't do anything, which is horrible because they then spread it patient to patient. They don't know they have it, and they bring it patient to patient, hospital to hospital, and it spreads like wildfire in healthcare. These are our 3 antifungals. These are the drugs we use for Candida. 85% of the isolates are resistant to the primary drug, fluconazole. 31% are resistant to our secondary drug. Luckily, we have one called echinocandins. That's our are tertiary, and that seems to work just fine. The problem is it's a very, very expensive drug, and most low and middle income countries do not have it at all. So it's essentially a rich country drug. They only have those other two, and you can see how resistant this bug is. So at the time, when we heard about this, when I got that call from Pakistan, the only reports of this bug were from Korea, Japan, India, Israel, Venezuela, and South Africa. Now, lucky for me, I had friends in every one of those countries except for Venezuela. We were sitting having a beer in Portugal at a meeting, and I said, look, send me your isolates. I've got the ones from Pakistan. Let's compare them all and see if this is something that's traveling around the world. So they did. And I didn't have the Venezuelan ones, but I've got a crazy Dutch friend, and he had a friend who smuggled them out of Venezuela into Brazil, and we got those isolates too. They came from Holland, and I had a material transfer agreement, so can't tell on me. So when we did that, what we found is that there were 4 very different strains that arose spontaneously in 4 different parts of the world, all at once. When we compare the whole genome, so there's 12 million nucleotides in their DNA, and when we look at the 4 and compare the 4 to each other, they were different between 40 and 400,000 nucleotides. So that's thousands and thousands of years. But when we look within a country, we see 10, 12 nucleotide differences, which is like 5, 6 years. So these things literally just appeared. And not only did they just appeared in 4 different places. We've since gotten isolates from more than 30 countries, 1,000 isolates, and we've shown that they're all those same 4. So we lucked out, I guess, that I had friends who liked beer all at the same time, and we ended up with all 4 of those different clades. This is the picture now across the world. Still the same 4 clades. It has literally gone all over the world. And we could trace it through patients seeking health care or getting injured overseas and literally spreading this. Now, the countries that are still gray, it's not that we don't think it's there. They either don't have the capability to look or they haven't looked yet. And one of the things I do right now, I go around the world into laboratories, ministries of health, and train them how to look for it, how to identify it. It's my favorite part of my job. But it was so important that it actually made the cover of New York Times. A fungus made the cover of New York Times. Fungus immune to drugs quietly sweeps the globe. This is the picture in the US. So in 2015, the only isolates in the US were the ones that I got from Pakistan. And within just another year, we'd identified isolates in Illinois, in New York, and New Jersey. And we could trace each one of those back to a single patient that received health care overseas. Over time, we started seeing more and more and more, and each time it went to a new state, it was brought over from somebody who received health care overseas. That was the picture until about 2019. In 2019, all of a sudden, we're seeing not only patients bringing it in, but we're seeing spread from state to state inside the United States. At this point, it's shown up in over 40 states, and every single year since 2021, we've doubled the number of cases in the US. 40% of patients who get this infection die. And it's not because it's a really deadly bug in and of itself, it's because the people who get fungal infections are already sick. They've already got something wrong. They're already in the hospital, and on top of that, they get this fungal infection that can't be treated. So it's devastating for the patients who get it. So that's what keeps me up at night. And it's not that one. There are two others. I wish I had more time. I could stand here and talk to you for hours. There are two other bugs, two other molds. One is a ringworm or tinea. One is this one here, Aspergillus, that's ubiquitous in the environment. Both of those are not only drug resistant, but once again, circulating the globe from a single common source. And we're finding it in country after country after country. In 2014, there were 0 human pathogenic fungi that were spreading. Now we've got 3, and all 3 of them are drug resistant. So something's going on. And with that, I will let you get back to the rest of the day, and I'm happy to have questions. So that's a huge, huge argument going on. So it has been found in a couple inland marshes, but those marshes also have human effluent. There are a few, one of the clades is only found in ears, the clade that originated in East Asia. We still only see it in ears. We found it in dogs, only in their ears. And there is a new clade that hasn't spread that they discovered in Iran, only in ears. So I think it started in ears. And there's a number of reasons. Ears are very high temperature, and this bug can grow at up to 42 degrees. Ears are very high salt. It grows at 10% salt. Ocean water is only 4%. This bug tolerates 10% salt. And ears are filled with antimicrobial peptides. So it have to be a bug that's used to becoming drug resistant. So I think it started in the ears, and I think it has, by us changing our flora, our bacteria, and our good yeast that live on us, it's taken the opportunity to invade our skin, and once it got in the healthcare system, that was it.
They usually get really dirty and most people don't clean.
Oh yeah.
So and humans tend to have dogs as pets, is there any connection there? Have you guys looked at animal models and what's going on there?
We haven't. We haven't looked at animal models of the ears. We haven't looked in animal ears besides just the dogs that they found it in. It's not a bad idea at all. Animals' temperatures generally tend to be higher than ours as well. Why adapt yourself to living at 42 degrees, which is 103, if humans only get to be. So, yeah, that's not a bad thought. Some people have thought maybe birds' natural temperature is 42 degrees. Their ears are open holes, so who knows? But so far, humans and dogs. Mm-hmm. We've never seen an infection in a dog. We've only seen colonization in the ears. And in the majority of people that get colonized, there's never any effect. But about 10% of people who get colonized go on to have a bloodstream infection, which is deadly. So what happens, and I'll give you this as an example. In California, they had 0 cases, but they decided to start screening patients. The places we see these are places where infection control is not very good. We have these things called long-term acute care facilities. They're hospitals where they send you when you're too sick to go home, but not sick enough to stay in an ICU or fill an expensive hospital bed. They're loaded with patients side by side by side by side. We also have these things called ventilator-assisted nursing facilities. And most of these patients are in comas. And the nurse just goes boom, 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 boom. Once it gets in, it spreads patient to patient. It can cover an entire room. You find it on the sink, on the floor, on the ceiling, on the equipment, on the bed rails, everywhere. And it spreads like that. So in California, they were screening urine, trying out this test that they developed, and they found a case of a person who was colonized. And so they went back to that floor of that long-term acute care facility, and they found 10 more. And they went to 5 other facilities that had had patients transferred back and forth, because that's what these patients do. They go bing, 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 back and forth. They found 100 cases within the first 3 weeks of screening, 100 colonized patients. By the first month after they started screening, they got their first bloodstream infection. And now it's all over Southern California. So because there's no symptoms in these patients, once one gets it, it's in a facility for good. So there's a lot of different ways that they become antifungal resistant. The most common are, so you know, drugs and targets are like enzymes, lock and key. So the drug fits into an enzyme and blocks the active site so it can't do its job. That's one way. So they have mutations, DNA mutation that causes that lock spot to not fit the antibiotic anymore. Another is called efflux. So they turn up, they're filled with pumps in their cell membrane, constantly pumping things in, pumping things out. And they overexpress these pumps, so as fast as the drug gets in, it gets pumped back out before it can reach its target. The other thing they do, fungi can add chromosomes. So they can just make extra copies of a chromosome and overexpress the target. So you saturate the drug by having so much target that there's extra. The drug just can't keep up with the target. So there's all sorts of fun things that the fungi can do to become resistant, unfortunately. Sure. I don't remember that one. But, I mean, we see brand new fungal species infecting people every single year. Number one, we're going into places we've never been before. But number two, the more successful we are in keeping people alive, the more petri dishes for fungal infections we're creating. So, you know, it's a real conundrum. We're keeping people alive that years ago would have died, you know, a long time ago. But at the same time, we're also making them susceptible to fungal infections. We didn't used to see them because we didn't have transplant patients who lived until they were, you know, 10, 15 years post-transplant. When I was growing up, we didn't have CF patients that lived past the age of 15 or 16, and now they're living to be 50, and their lungs are filled with fungus. So we're seeing all sorts of things that we've never seen before. We're creating drugs that make patients immunocompromised in ways we've never done before. And so we're going to keep seeing new rare fungi in these same patients. If you read the medical journals, there's, you know, a new fungus causing infection every month or so, depending where you are in the world and how serious you want to call that infection. So it's going to keep happening. All right, no more questions. Thank you for having me.